is greater than 360, just take out rotations and you end up getting an angle that's easier to think about. Because, correct me if I'm wrong, it's easier to think about a 50-degree angle than it is a 410-degree angle. Because when I say 50-degree angle, you say, ooh, quadrant 1. Ooh, all the trig functions are positive, and you can start playing with triangles for that. You could start talking about the sine of a 410-degree angle would be the exact same as the sine of a 50-degree angle. Why? Because they produce the exact same side. It's the exact same position of rotation. One's off by 360 degrees, but it's the exact same thing. For that matter, you could say the tangent of a 410-degree angle is exactly the same as the tangent of a 50-degree angle. And why? Because a 410-degree angle and a 50-degree angle are essentially the same direction. Mathematically, it's the same direction. Mathematically, pin the tail on the donkey is no more interesting spinning the person than not spinning the person. Of course, physiologically, it's completely different, but that's the whole point of the game. But mathematically, exactly the same. So I could give you any angle. I could give you any angle, like, oh, give me an interesting one. Nice. I could ask you to compute the sine of a negative 765-degree angle. Interesting, right? And now you know that if I spun you around enough, you would spin around negative 765 degrees. I'm just going to have to keep, I have to start spinning you down, because that's the negative direction, and just spin you once, that's 360 degrees, twice, that's another 360 degrees, and who knows how many more 360 degrees. But the nice thing about this is, knowing that this angle is more than one rotation, because it's more than 360, you could just start taking out rotations, and you'll get the same sign, because you'll get the same direction. How could I, in this case, work closer to an angle that I'm comfortable with? What you want to do, if you're way out here on the number line at negative 765, or even if you were out on the number line at positive like 1080 or something, you want to work back to where you're between 360 and negative 360, because then it's going to make sense. So in the case of negative 765, you want to work back to that region. So how can you do that? Well, add 360 and see what you get. That can be kind of done in one's head. 5, 0, negative 405. Haven't got there yet, right? Because we're still not within a range that we're immediately comfortable. We should be immediately comfortable with an angle if it's between negative 360 and positive 360. We should have an idea of what quadrant that's in. So add another 360. Negative 45. Ah, how nice. So if we take out rotations, we can get ourselves into this comfort zone. Because when I look at a negative 765-degree angle, it's the same exact direction as a negative 405. It's the same exact direction as a negative 45. Well, why don't I just think of it as a negative 45? That's going to put me off here, right? All students take calculus. Do you guys have an acronym that's better? It's not important. All students take calculus. It's a phrased, but fine. You're down here, so your sine is going to be negative. You know that much because we're down in this quadrant. And what's the sine going to be? It's going to be the sine of a 45-degree angle. You know a 45-degree triangle. You should. You should be friendly with this guy by now, right? 1 square root 2. So what's the sine? 1 over square root 2. In this case, negative 1 over square root 2, because you're in a quadrant where the sine of that triangle is going to be negative. And simplify that in terms that are attracted. There you are. Have I said before that that's okay in this class? No. honestly, I really don't care. I mean, when it comes down to it, this is more proper. Because whether you eat your salad with your mouth open or not, you're still eating your salad, right? I think that was the analogy I originally used in Algebra 2, was like, why don't we like square roots in the denominator? It's not proper. Why is it not proper? Because somebody said so. Because maybe it doesn't look right or feel right or whatever. But it's the same number, so it really doesn't matter. The point of this lesson, though, is if I'm at negative 765 degrees, I can go negative 45 degrees and get to that angle. I could also go another 360 degrees and have gone negative 405. I could also go another rotation still and be at negative 765. But it puts me at the same point. So should you be thrown something like this, just work your way back to your comfort zone, and then you'll be good. So we are in section 36, and we should take a look at 8, summation notation, 12 through 17, inverse functions and shifting graphs. Let's also look at 19, that's exclamation points. I can't remember what those are called right now. Factorials. Let's also look at 24 through 26. That's some function work, and specifically, you'll get some angles that are bigger than that, bigger than 360.